Shabbir, go ahead and mute your mic, turn off your camera.
What they could do is
the bubble out there. And I'll be going through a couple of products which Microsoft has gotten, namely Power BI, the Power Query, the Power View, and the Power Map and stuff like that. So this is where my focus would be, and I'll be showing how a typical business analyst or a power user can start using Excel and pretty much make his own data models and start making some analytics out of it. Now, Power BI from Microsoft has got two main components. You'll see one is the Excel part of it, and the second is the collaboration where comes the SharePoint and Office 365. Now, before this, I jump into the next screen. I want to know how many people out here have used Excel or have used the self-service components of Excel? You guys, okay, good. Anybody into the advanced analytics, machine learning, Azure environments and everything, or nobody has touched that? Okay, fine. And we might go for that one if we have some time, but I'll stick to my Power BI components mainly. So what we have is the two main advantages which we have in Excel is, one thing Microsoft has got is we've got the Excel to do the self-service. So pretty much everyone in the room must have used Excel some way or the other, and everybody's familiar with Excel, like making the pivot tables, pivot charts, or basic like tables and everything. So Microsoft has got Excel as the main component for Power BI. So as a power user, as a normal user, there is a very less learning curve for anybody to start with analytics. And everybody know out here that BI and now is the main thing. Everybody wants to see their data, want to analyze, and Excel helps on that stuff. So you have three components, which is called the Discover, Analyze, and Visualize. The three main components are the Power Query, the Power View as the second component, which is the Visualize. The Analyze is the Power Pivot, and you have something add-on which is called as Power Map, where you can do some exploring of your data over a globe and all that stuff. And then this part of the side is the collaboration part. So once a user has developed their model or their reports, they would want to publish it out to the organization, like corporate people, to see those reports. So that's where the Office 365 comes into picture, or the SharePoint on-prem if you have an environment. And you would share that. There are a couple of other features. You can have it on mobile and all that stuff. And I'll go to that part also. So I was going through the very basic out here. The first one is the query part of it. So I'll go to the next screen. This is the Power Query. Now, think about this as more of like, if you go into a corporate BI, you would typically have something called as SSIS, which is the integration services from Microsoft, where you do all the cleaning of the data, getting your data from a source, multiple sources, and then like a massaging, cleaning it up, and then putting into a warehouse. That's where your Power Query comes into the picture. Now, if you think about a corporate BI solution, SSIS is one of the solutions which Microsoft has, and it's more of an enterprise solution. You would need an IT guy, a developer, to learn the whole tool and start using that stuff. What the good part, the beauty part about this one is, you have pretty much an Excel interface. A user can just write basic select statement or checkbox some of the tables they're looking for, and they can have that data into that system. So that's a very easy way to start learning or getting the data into your system. So you'll see it's transform and everything and the merge, and then the next part to this one is the Power Pivot. So once you've got your data from all the multiple sources, maybe say it's a SQL database, it's a raw text file, or some, let's say, Twitter or Facebook or some unstructured data. You can get all that data into this through the Power Query into the next level, which is called the Power Pivot, which is the data modeling part. So people with a little bit of experience on the data warehousing and stuff like that would have an idea that, okay, this is more of like an ER diagram where I'm trying to connect my facts and dimension. I'm not sure if you guys are familiar with facts and dimension, or should I take it? Okay. So facts and dimension are nothing but a concept in data warehousing where you would need your dimension to slice and dice your data. Say, for example, you have a sales information and you want to look your sales by customer, by products, by date, range, all that stuff. That's your dimension. So you would have those type of structure, which is over here. You'll see you have a time dimension. You have something called a shipping information, some CSAT scores and everything. So that's where you would use a Power Pivot to do all the modeling for you. So you got your first step was you get your data from the sources into Excel, and then in Excel you use a Power Pivot engine, or it's more of called as an Excel X Velocity engine, which is a new concept which Microsoft has got into Excel 2013, where you would do all this modeling. So you would have one-to-many relation and set up all those key formulas and everything, and then have this thing published onto a maybe it's a SQL server or a cube type. The end product of this one is more of like a cube. So if think about from a A corporate BI solution is more of an SSAS, an analysis services where you have your cube deployed onto an engine and you are trying to slice and dice the data and making reports out of it. The next part is the visualization. So you got your data, you got your cube created, and the next is now you start making those reports out of it. So till this point, the second step would be more of like a guy who is a power user, a guy who knows a little bit of modeling type of thing, and he would publish that system or that particular data into an engine, and this part is more of at the end user. The user would actually go and start making his own reports. So if they know and understand the data a little bit, they'll start making these reports directly. And it's again an Excel sheet. So if you are good with pivot tables, pivot charts, this is the same thing. You'll see like on the right hand side, I'll show that in the demo part, you'll see a pivot table type of a list of fields and everything, and you have a canvas where you can drag and drop your fields, and you can start making your reports out of it. These are very good, like you see, like this 9 charts, bar charts, pretty nice. Like all the feature and functionality you would see in a typical graphics visualizer. Like say for example, some competitors like Tableau, ClickView, those type of competitors, they're pretty much on the same lines. So you see the same graphical presentation. This was the fourth part. I was talking about the exploring part. So the first part was you got your reports, basic reports, 2-dimensional, 3-dimensional reports. And if you now look at more of a 3-dimensional exploring your data on a say a global like Earth or something, and you can see this data like it's pretty nice. Like so again, add into the Excel, and you can have movies made out of this. So you can actually make movies and have this into your presentations. So you can make like a MP3 file or MP4 file and have this presented out to the end user. So you can publish it onto the globe, and like people can see it directly. So once we've got the 3 components, like say for taking an example of a power user, a person who creates your reports and everything, they would want to publish that particular report to their company people out, want to share to some more people in the team. So that's where you would be using your Office 365. Now this is a new on-cloud SharePoint environment which Microsoft has brought in. You can have 2 flavors of that. One is like SharePoint on-prem, so you can have your own servers, you can deploy your SharePoint locally, or you can use the Azure, the SharePoint online environment, which is called as the Office 365, and you can deploy your charts and everything on this one. And people can like pretty much see the whole thing. You can have your security, you can assign people who to see what and everything. In this one, in the Office, there are mainly 3 components. The share part, where you said the collaboration part, you can share to people, have those accesses. This part is a very cool, a new feature which has got added to the cloud version. Now, this part, the Q&A is not available on your SharePoint on-prem. So it's pretty much on the cloud. It's more of like, a user at the C level. Say an executive wants to see a report. He doesn't know anything about the data model behind the scene. He has no idea on that stuff, what things to pull in and make the reports out of it. But then he would type in some question. So it's like a Bing bar. You can type in, okay, I want to see my total sales by year. It will make a report for you. So that's like an auto, like it's more of a natural language. You can type in your natural language, and the system will understand behind the scene what the models were published, and based on that, it will make the reports out of for you. So that's a pretty cool feature. I'll show that on the cloud right now. And the last part is the mobile. So you have the same reports and everything is all like mobility compatible. You can see it in Android, you can see it in iPhones, iPads, everywhere it's available. So all the reports which you publish in cloud, they're by default, they're compatible with all the mobiles. So you don't have to worry about that stuff also. This was the slides I'll run through quickly because I want to show off the demo part of it mainly. So this is like how the Power BI site would look like in Office 365. You will have all your thumbnails, like reports, and you can click on that and you can see the reports out of it. I'll just run through it. This was the question and answer I was talking about. So you can see show my customer by total revenue and the total number of employees. This will present the whole graph for you automatically. And then it gives you all the options. I can have okay, I want to see a map, for example. I want to see a table out of it. Or I want to see a bar graph of it. I can see all that stuff. So it gives you suggestions at the same time also. And this is the mobile part of it. So you have apps available in Android, in iPad, iPhones, and also in Windows. I'll jump onto the demo part of it quickly. So what I'll do is I'll open a very blank Excel sheet and I'll quickly show you guys how easy it is for a user to create those reports. Within like 10 minutes, you'll see like the whole report is pretty much ready for people to use it. So I'll create a new Excel sheet. I'll just say, for example, I'll open this sheet. It's Office 2013 version I'm using out here. And with Office 2013, you have pretty much all your Power BI components add in itself. So you will see, like, for example, on this tab on the ribbon, you'll see Power Query, Power Pivot out here, and Power View is nothing but it's out here, you see Power View. So three components are pretty much added with Office Excel 2013. If for any chance you have an Excel 2010, you can add these things. So it's not that if you are on a lower version, you cannot use it, but you can add those things as an add-in. You can download it from the site and you can use it. So what I'll do is I'll start with the Power Query. Now, two main features which Power Query has, like, if you can see this particular thing, a ribbon out here, it says you can connect to any databases you want to. So you can, for example, you will see the list out here, you can pretty much connect to any of the third-party sources, like an IBM DB2, for example, a Salesforce, or like in a SAP Business Objects data model. So you can pretty much connect to any of the third-party tools available to you. So it's not just it's good to a SQL Server or something or a text file, but it's available for everything. You can also do like Sybase out here, Teradata, pretty much everything, Oracle database out here, so pretty much everything. So in this time, what I'll do is I'll connect to an Access database, which I had made a sample before over here, and I'll try to connect to that one. And I'll use this particular file, for example. Now you'll see on the navigator, it shows me the list of all the tables which I had, like all the dimensions and facts and everything. And I can pretty much click on any one of them and it will show me the data which is available out to me. What I can do is easily, I can just click on this load and I can say load to, for example. And it will create me a new table out here and I can use that data as my source for creating the pivot tables down the line. It's as simple as that. You can pretty much use this particular sheet out here and you'll see your Excel sheet is available with all this data and you can pretty much import that into a pivot table, which I'll show you in the next video. The other good part over here which Power Query brings about is the online search. So think about an example that you have your corporate data, you have your database systems available and you know what data is, say sales or financial information or something like that. But then if you want to try to connect this with something like a Wikipedia or a Craigslist, for example, you can do that stuff. So you can go online and I can pretty much type in something over here. You see on an online search, I can say list of, for example, USA states. I just want to throw this value, and I can look at the data available online, and you will see for example, it has gone to the Wikipedia and it has pulled out this information for me. So I can pretty much say I want to use this thing, and I can say edit over here, and it will open for me a. You see, this is downloaded from the Wikipedia system, and the data is available to me. So what it does is actually it is reading an unstructured Excel or an HTML content. It's not doing anything else. It's pretty much like a basic HTML page, and it is passing that data into a table for you. So you can use this as maybe doing some more insights, more say if you are comparing your revenue or your company's say revenue, financial information, and doing a comparison with top 10 companies across the board, you can do those comparisons, where you stand, all that stuff. And this is pretty much the latest available for you. So you can go to Wikipedia, any of the sites you have. And you can do a lot of ETL type of format. Now ETL is nothing but you are loading some data, cleansing some data, removing some fields which are not required. Those things are also pretty much available for you very quickly. So for example, in this particular team, I don't want to have this particular field out here. So I can just say remove. This will remove the column for me. So whatever information I need from that web page, I can pretty much extract that data, whatever I want. And I can also do all the parsing. I can clean up some null values, for example, all those database concepts you can pretty much apply out here.
Excuse me.
Yes.
Do we have to tell the site from where the data is to be taken?
No, you can search. So you can just type in a natural language, just type something, and you can see a list of things which comes up on the right hand side. And you can pick up whatever is relevant for you.
for example, if you want to put that top 10 performing companies in USA in terms of sales and profits,
Yes.
will you give that data?
Yes, it will. So you can type in whatever natural language you have and it will show you the data. And if you have a URL, yes, you can type that URL also. For example, you have, I'm just throwing out a value, say usatoday.com, you have a site available which shows all the latest info. Yeah, you can type those URLs also. So you can do that stuff.
A quick question.
Yes.
So when you're talking about your powered querying option or functionality, and when you brought in the Access database, is there maximum number of rows that Excel will
No,
have?
so in Excel, if you are using an Excel 32-bit, so there are two flavors of it, a 64-bit and a 32-bit.
Okay.
A 32-bit will allow 2 gigabyte of files available to you.
Got it.
And if it is a 64-bit, it's like 8 terabyte or something, which
Okay.
is huge. I mean, like, you know. And again, like to capture this question, say for example, a user has got a 32-bit Excel on his local machine, right?
Right.
What people would typically do is they would create that model locally with a subset of the data, not everything, but just a small subset of data, and then publish it into an analysis services, and have that analysis services do everything, the whole loading of the data. So that's like, you know, sky's the limit. You can do anything. So I'll jump out of this one. I'm running out of time. So this was the query part of it. I'll discard this one, and I'll show you the pivot model out of it. So you'll see, like, you know, I had created a sample out here. Now this is nothing but a data model which was used based out of that same database which I had shown you, but I had put out a couple of information like the customer, the sales, and everything. And that's where it comes. This is the screen which I had shown you in the presentation, the data model. And you will see over here in this diagram view that same information. So this is how the information looks like. You have pretty much like a star schema. If people with their warehousing would understand like what's a star schema like. You know, you have that facts and dimensions, and you're pulling out information over here. You can create your hierarchies. You can create KPIs. You can add your measures. KPIs are nothing but like, you know, those threshold values you want to assign, and you can have like, you know, that traffic light information available on the reports and stuff like that. And hierarchy is nothing but, for example, a date hierarchy. So you want to look at your report based on a year first, then month, drill into the month, and then the day and something like that. So you can do all those type of things over here. For example, in this one, you'll see like, you know, I have something called over here. In this one, product over here. So you see the product has got category, subcategory in the product. This is nothing but a hierarchy. So you can, when you're looking at a report, you can go all the way to the product level, or if you want to like summarize it into subcategories or categories, you can do that type of thing also. So from this, I'll jump onto the report part of it, the Power View. I'm opening a Power View sheet out here. It's nothing but it's like a new canvas, a new sheet in Excel, and you will see your Power Pivot or the data model fields available to you. Now this is pretty simple. Like if you want to create some report, I can pretty much like, you know, for example, go to my sales. I can put like, you know, my gross sales, for example. So I can like select this one, and you'll see like it comes on the canvas over there. So the information comes to you. I'll show it over here. So this information comes out here. Then I can like pretty much like, you know, use my, say I have my product out here. So I'll use my category, for example, and you will see like, you know, my category comes out here based on this one, and the data is available to me. And then I can pretty much change this thing. Say if I want to make it a column, clustered column or something, I can change this thing into a column chart out here. Pretty straightforward. If you have your model right, you pretty much can do anything with that data. You can have your line charts, your bar charts, your globe, your web. Like if you want to look at your distribution of your products on a region base, if you have defined those geological information, you can pretty much present those things out here. Now the same thing, suppose we have made this report, and now you want to publish it out onto your cloud. So I have got the cloud environment running out here. I'll show this part over here. So this is my cloud environment, which I had shown you in the screen. And this is, say for example, this was my report which I created again based on that same data model which I was showing you guys. So this should open for me the report.
You may have mentioned this, but is there a cost to this, or does it?
Well, if you get your Excel 2013, this is add-on. This is free.
Okay.
So a user. So that was a very good point you brought up. The most important other thing is when you get an Excel 2013 license, you don't have to worry about those additional licensing for making your reports and everything. Like for other other third-party components, if you have to get something, you have to buy a license for that. You pretty much are available with this one. Same thing applies for a SQL Server. If you have a SQL Server license available, you have your analysis services, your reporting services, everything free. It's added. So that's not something which you have to buy additional. Try on a different machine if I can try that stuff. Let me see if I can do that stuff over here. Sorry. Looks like I have to block this thing. Nothing is got blocked. Trying to open the
What's that? Should be. You're running a dark computer, so if you have internet, you should be all set.
Just trying to finish up this install on this one. I'm not sure why it is. Okay, so hopefully this should work. So I have my Power BI site, and hopefully that stuff works. So this is the cloud environment which I published my whole dashboard. I'm trying to log on to that cloud environment, the Office 365 account. And you'll see this is my financial dashboard. Okay, it works. So this is the dashboard which I was talking about. The same data which we showed you guys how to query from the database, Access database, do those reports, and then publish it out to cloud. So this particular light, or this is what is the KPI I was referring to. You can show this KPI that okay, how my company is doing with base to the expenses and with base to the sales the company is performing. And you will see this particular report is all dynamic. So you can play with this report on the fly. So you can click on, say for example, this one, and you will see my data changes out here. So I can focus on a specific sales expenses. I can look at my manufacturing expenses, how am I doing individually for each of the departments or each of the components, and I can pretty much make it more interactive. So it's not just a static report based out of something an IT guy or developer has published, and then that's what you live with. You can pretty much have those interactions with the report. I'll show you a couple of other reports. One of the cool reports which we made. Now this is a bubble chart. Now in a typical report you try to make a report based on your x and y coordinate, your two-dimensional coordinates, right? This one is more of like a 4 coordinate. So what is doing out here is this bubble, the size of the bubble is showing you the sales, the profits and everything. It is showing you the categories, the touring bikes, and then along with that there's a play axis I cannot show you guys on the screen, but when you play it on a date, you can see how my data is changing. So this is more of an interactive graph where you can see over a time period how my sales is behaving. So I'll say, for example, I'll stop over here. For example, if I'm looking at my, say over here, if I go back, and if I'm looking at my, say, mountain bikes, when I click on that, you will see how my sales got changed from, say, if it was looking at a date dimension from 2012 to 2014, how is my sales doing? So I can see all this trend happening. And if you closer look at this particular graph, you'll notice that there's some sort of a trend which says that on a summertime my bike sales goes up, and my winter time the bike sales goes down, which is still normal. Like people would want to use their bikes when they are in summer. They can drive to work and stuff like that. So you will see there's a trend out there. So that makes sense. So those type of information is available. All these graphs. There's one other thing which is like a forecasting. Now over here, this forecasting feature I cannot show you over here, but I'll just try to explain it over here. So this is the line graph which we have over here, the sales amount by date. Now if you do, I cannot show that part in this screen, but if you look at this particular bar and if you want to project your forecasting, you can do it over here. So Microsoft gives you that data mining option also is also available to you free. You can do that stuff. They use the basic clustering and the regression algorithms. And what you do is you assign a period to it, at what period I want to do my forecasting for, and it will show you a projection how your sales would be based on your data, on your historical information. And you can change that data. So if I want to say, okay, it looks more of realistic, but it's not something realistic, it will have to have some deviation. So you can assign those deviations to it, and then that report you can send it back. So you can download that report locally, and you can have those budgeting and everything. So typical this forecasting would be used for budgeting. Like if you are budgeting your next year, how you would do that. So you would have those deviation assigned to it, and then you can download that Excel file and use it in your local machine.
Can you just show how that kind of report will look like?
It's more of like I cannot show you over here because of that screenshot.
You can just move
it's not
screen a bit, something new like this.
The typical would be like I'll show you if I have the output, I'll show that part. Or if it's not, then maybe we can take it offline. I can show you afterwards. I can show you afterwards for this session. Okay. So it's more of like an Excel output. So you will have your sales amount. So whatever you have on that graph, you will have your sales amount and your date, and then you will have the projected value. So there will be 3 columns to it, just to try to visualize the whole thing.
All right. Well, thank you very much for presenting. I really appreciate it. All right. Let's go ahead and move on to yours. Thanks. So you have your entire screen share on the Hangout. I'll just go back to that. And so you can click here. And screen share for you is great. Yeah. And we'll just do desktop. Share screen share. Okay, and all you have to do is minimize that. Keep it running. Would you like a PowerPoint clicker?
Yeah, great.
Awesome. Thank you so much. Steal this back for you. And see how
Thank you guys. Thank you.
Thank you.
If you have any question, we have a booth downstairs. Pretty much like you guys have any question, I can show you guys. I'll show you the forecasting part.
I was there.
Actually, this. Thank you. Appreciate that. And yeah, we can bring yours in here.
I am now.
BG adjuster. Stu, is that there? Thank you so much.
No, we're doing
Yeah. So we have a few first. Oh, I think it's switch. Oh, you might need to go into your settings. So there you go.
All right. Hey everybody. My name is Wesley Passifield. I am a student in Northwestern University's Master's of Predictive Analytics program, and I'm also a client manager for custom analytics for the Nielsen company. And today I'm going to talk to you nothing about custom analytics for Nielsen, but I submitted one of my papers from Northwestern into this conference, and it was published, and I'm going to talk to you about that today, which was a objective clustering analysis of U.S. undergraduate universities. Kind of an odd subject, but I just found it very interesting and something I'm kind of passionate about. So, sort of the how this was all stimulated was we had a very open-ended assignment where we just basically had to use machine learning to solve some sort of problem as our final project. And college tuition is just going crazy. It's risen something like 30x in the last 30 years, just way more than inflation. You're asking 18-year-olds to make decisions that are going to impact their financial future that they don't fully understand. Conceptualizing that much debt and what that really means to your life is just difficult. So what I wanted to do is to provide a more objective analysis of colleges. Most ranking systems are extremely subjective. I remember when I was in school, we literally were told to fill out these surveys because it's going to boost our rankings, which is a ridiculous way of rating colleges if you're biased that much. So what I wanted to do is just completely unsupervised, completely no bias. Let's just cluster them and see how they look. I only got 15 minutes. I'm going to go very quickly here. So I got all the data from all of it's free, all of it's available online. The iPad's educational statistical database has a ton of info. And then I also integrated payscale.com data, which showed an expected salary post-graduation and then also mid-career as a way of sort of evaluating what these colleges are getting you from an ROI perspective, not just admissions, et cetera. The most recent available data that I could find for everything I needed was 2011, 2012. The way colleges work, I can't imagine there's too much of a difference from 2011, 2012 to right now in terms of like the ways the schools are comprised. And then I got 456 schools I was able to find all this information for. So that's sort of my modeling universe. So I standardized everything so I could view it on like a Euclidean plane for clustering analysis. And I broke it down into 6 different groups. The bottom's cut off, but institutional characteristics, so like what the very basic composition of the schools. Where is it? How many people are in it? Public or private? Admissions criteria, so how many people got in? How many people that got in actually went, the matriculation percentage, and then standardized test scores. Not every school's on the SATs, but when I didn't have SAT scores, I just converted it to SAT based on what their ACT ranking was. So that's all in the same playing field. Finances, so tuition in-state and out-of-state, financial aid percentages, student loans, etc. Demographics, so percentage by ethnicity, percentage by gender. Academics, so major distribution, student faculty ratio, and then finally the financial stuff, graduation, expected salary, etc. So just very brief methodology discussion. I used a K-means clustering technique. I tried a variety of clustering techniques and actually used those techniques like density-based and expectation maximization to inform ultimately the K I chose. So for those who are not aware, K-means is you select K equals the number of clusters you're going to use in the model. So I ended up netting out at a K of 10, so 10 different clusters. And each cluster had unique characteristics that defined it from all the other clusters. Now, schools are very unique. Each school has its own unique characteristics. So one thing I stress with this is that there's a lot of variability even within each cluster. Each one is unique. Each college has similarities within its own cluster. There's also a lot of variability. So it's not going to be, you can't just characterize schools in one lump because everything's unique. But at the same time, there's a lot of characteristics that are similar amongst the schools within each cluster. And I have a Tableau presentation that I'll kind of work through that gives in more detail about that. So there's some trends existed cross-cluster. Like I said, each cluster is unique, but some trends were very consistent. So when the clusters were created using this algorithm, public and private schools were extremely segmented. There was very little public schools. So essentially what netted out is public school clusters and private school clusters. There's a couple exceptions to that, one being BYU, for example. It's a very inexpensive private school, so it actually got lumped into a predominantly public school cluster. But for the most part, it's very segmented public and private school. But then within each cluster, each one has sort of its own little characteristics, and I'll briefly go through that in a bit. All right, so I'm actually going to switch back over here and go through the Tableau presentation. So this is what it looks in a stagnant format.
Actually, we can just do settings so we can hear the screen because we're not.
Settings.
So just go to system settings. Go to display real quick. And orange. And here.
Okay, cool.
Thanks, we will go back up.
All right, cool. So this is the visualization from a geographic perspective of how all the clusters netted out. So I have all of them selected now, but I can tab through real quick. So one cluster that got created, this is what I call the big national public school. So these are all public schools. The size of the bubble represents the enrollment. So this would have to be a very large school cluster. The schools in this cluster are very large enrollment, and they're nationally spread across the country. So what that means, region was one of the variables I used in the model to create the clustering. So that means that since it's so scattered, these schools have very defined characteristics of outside of geography that made them group together, which is interesting because in many cases, I'll do another one, geography was the most important one. This just ended up being a Texas cluster because they were schools that were relatively similar all in Texas. So you had different types of clusters sort of emerge in that way. Now, another way of visualizing it, so these circles here, you can't listen to the labeling, but these circles here represent different clusters. This is admissions, so let me walk back over here real quick. This top cluster here was what I call the high-risk, high-reward cluster. So this is extremely small, extremely selective private schools that are unbelievably expensive to get into, or to pay for. So this one right here is admissions percentage. So you can see this is the private school clusters. The y-axis here is standard deviations from the mean. So this one is significantly more difficult to get into than all the others. This right here is the purple. The purple one is the big, large national public schools cluster. I note that because I'm going to go to the next tab, and I think there's some really interesting trends that emerge from that I personally wasn't aware of. So actually, sorry, my work. All right. So this is like me doing the analysis. Like I said, it's extremely unsupervised. I wanted to imprint as minimal bias that I had as possible. So one thing that I was I just didn't know was going to happen. So these all right here, this is in-state tuition. Sorry, in-state tuition. These are all public schools, extremely inexpensive relative to the average. Okay, cool. So in-state tuition. So then you got this right here. This green one is that's another private school cluster. This is the extremely selective private school cluster, the most expensive. Like I said, high risk, high reward. Hard to get into. You pay a lot, but then as we get to later, you make a lot of money. The green one here is less selective, but still extremely expensive private schools. A lot easier to get into. You don't make as much after college, but it's still super expensive. So note the in-state, all the public schools here, that purple one down here, inexpensive to get into in-state. Now we go to out-of-state tuition. Notice that the purple one jumped way up. So even though it's a public school, it's almost as expensive as these private schools to go to, despite being a public school out-of-state. I wasn't expecting to see that. I just assumed the private schools would just inherently be more expensive. But these national-style public schools are extremely expensive to go to out-of-state. Which I found really interesting, especially given that most of the public schools still remain well below average outside of that one anomaly. As we'll find out, it's worth it because those schools end up paying out, and they have very unique characteristics. So if I go back to the original graph I showed with the geography and how that purple cluster was all over the place, that's because it's so unique relative to other public schools. Even though the geographies were different, the characteristics that comprise those, like institutional characteristics, et cetera, tuition, academics, the schools in that cluster had extreme academic specialization, real emphasis on STEM programs, so like engineering, et cetera, highly technical degrees, which do lead to higher salaries. So it's a very interesting sort of trend. So let me go to the finances real quick. So keep an eye on, what I found the most interesting are this yellow one, the green one, and the purple one. So the green one, much more expensive than average to go to. All right, so this is average pay, these first two right here. Average pay right here at graduation, and then mid-career. I'm not entirely sure how the pay scale, I got all this information from pay scale. how they determine mid-career or what they define as mid-career. But the easiest way to view it, I mean, most of the time it's pretty consistent. If you get high pay right after graduation, it's pretty high pay mid-career either way. So let's go to the green ones first. Notice, remember, green was really expensive, just at average for your salary. So you're paying a lot, you're not making that much money. So from an ROI perspective, these green schools might not be your best bet. They're private schools that really aren't that hard to get into, and it shows by your salary. So if you're 100% trying to make like a ROI type college decision, these might not be the best schools for you. Now if we go to the purple one, extremely high right after college. Those are the public schools, the national public schools. Then as close to what the very selected private school cluster was as well. But as we get to mid-career, they expand out a bit. I've got a few theories as to why that happened, but I found that to be that gap to be pretty noticeable, much more noticeable than I expected. I'd expect that mostly coming from, you have in the small private school cluster, there's a lot of business majors and stuff like that. So you come out of college, you might not make as much money, but there's a higher salary trajectory as you move up through the ranks. With the highly technical degrees, you typically make a lot of money coming out of school, but there's less of that like huge upward possibility. So sort of an interesting trend there of you make a lot right away, but then you don't see it quite as much of a increase as you go along. So I only got 2 minutes left. I open up for questions here, but that's sort of just this whole thing is better with an interactive session anyway. So like that's just sort of the concept I had for this whole analysis. I have a whole breakdown of all 10 clusters that got created and what they mean. So sure.
Could you say again the software you used to do that?
Yeah, sure. So I did. So this is Tableau that I'm visualizing everything, but I did the modeling in. I used 2 different softwares. I used R and I used Weka, I'm not sure to pronounce it, to actually run the clustering analysis.
Can we go back to the map to see where the yellow and purple are?
Yeah, for sure. You want to look at yellow and purple?
Yeah.
Yeah, so these are the, I found to be the most interesting ones, and I think that's sort of shown here. The ones that I found to be a little less interesting were the ones that were just geography based. Like the Texas one, they're all in Texas. Like, doesn't take a clustering algorithm to tell you that. But these have extremely defined characteristics, which is why they're so all over the place. A lot of it has to do with the expected pay and the extremely high tuition, et cetera. Another thing to note is, I know it's kind of hard to see from your angle, but how much smaller the yellow is versus the purple. The purple cluster is really huge public school. So the yellow is almost exclusively very small private schools. So they're extremely different schools, and it's kind of interesting because you net out in a very similar place. So just as examples, purple is like University of Michigan, UT Austin, which is extremely interesting because there was literally a public school Texas cluster that got created, and that was omitted from it because it's so different than the rest of them. This actually I found to be the most interesting. I actually live in California, but I'm a very new resident. I didn't know what the difference between the Cal State and UC schools were in California. Every Cal State got put into cluster 2, and every UC got put into cluster 4, which is like completely, I was just like kind of blown away by that. I couldn't figure it out at first, like why is this happening? It was really that in-state, out-of-state thing I was looking at before. All the Cal States extremely cheap in-state, extremely cheap out-of-state. All the UCs extremely cheap in-state, extremely expensive out-of-state. And also a much higher emphasis on technical degrees. So much so that they got like defined that cleanly. All Cal States, all UC in different ones. So it's kind of interesting stuff that came out. Anything specific you want to?
No, just cool to see on the map.
Yes, yeah.
Interesting stuff.
I think I'm out of time. Maybe any last questions? And I have like a Tableau public thing that I can share the link if anybody's interested. You can just cruise around. That's in here.
Thank you very much.
Thanks.
All right, we're back on track. We're going to take a 5-minute break instead of a 10-minute break. We'll be ready for our next presenter. See you all at 11.
Yes.
Okay.
I just gotta figure out. No, thank you. Just now.
You want me to tell you that?
It doesn't
with your handstand coffee cup? So just.
That was what-
Yeah, actually, I just. So I
So why don't you give us a-
It's very, so it's just more just an exercise. Yeah.
We just have smart, or
Yeah.
is that the same?
Let me see if I can go find something. And just when you're doing it, just make sure that right on the, not on the.
I didn't know. But you can run like closer now. Yeah, exactly. So, but what I'm trying to say is that will.
I'm afraid to come back to one of the other sessions.
No, I think
I
that.
was in Google, I have some good ideas.
Yeah.
Something.
Is that enough?
If you want to go somewhere else.
Yes.
Yeah.
Yeah, I mean, I think if money wasn't an issue, that would
Well, what do you have to hire some guys to you know, I think it just meant to value the value. Like exactly what you said. You can actually see the so like you're gonna just like a goes
We have tape up here.
and also these are flying.
No, don't worry about it, that's fine, what I just like, because that's what we did, is really worried about, yeah. You know what, you want to,
So, you know, if I was in other things, well.
you want to use this computer for Gene?
This one?
Yeah, I think so.
Yes.
Yeah. You can share it with yourself, that's right.
Very, very. Probably. I mean, I did this.
Yeah, that's what the.
I mean, I didn't do anything
Sure.
extremely. That's the thing, I didn't do anything extremely complicated. So.
I was thinking, tomorrow with your laptop real quick, just to test this out. Thank you so much. Ship this off
Yeah.
please. So there's, so that's, yeah, so it's working, I just have to mess with the settings with it.
Yeah.
That's fine. No worries.
So I did
that.
I took a class.
Boom, perfect. Okay, that'll work great, and then we can still present on that.
Yeah. Change it to desktop.
It should be more.
There's that.
Yeah. This is.
Thanks so much.
Oh,
I
no problem.
appreciate that. Yeah. So this was
Yeah. Or just,
okay, so we just, We'll check that out. Awesome. So we're going to do Chrome. Yeah, that's what I was planning to do. Here, set up into the Hangouts, just a solo screen. And then we'll get her logged in via Firefox. Thank you.
Yeah.
Anyone else doing demos, like actually needs their computer close to, you're going to do demo? Anybody else? No, you're good now.
Yeah.
So once she deletes this, to Hangouts, so we'll do, is that your email, right? So did you invite your?
Oh, the big.
Yes. No, 435. It's going to be cheap.
Okay, yeah, that's what I'm saying. I thought it was
He's got your phone.
Yeah, but I heard 436 that just became available after. Yeah, so yeah.
That was awesome. I was.
Then you do share trade.
I needed one last elected.
Yeah.
Okay. And funny, it was the project was just the one.
Yeah.
It's
You like it?
Wow, that's great.
Yeah,
That's great.
And to me, it was so he's been.
He is.
Available.
He is. Yeah.
Outside of dividends, no,
Yeah, it is. I'm thinking about it.
Exactly, like a So you commute like a
Yeah, it was online.
Sure.
Gotcha.
Oh, yeah.
Just today.
Well, you got your job right before.
Mark, I did kind of the next year. Analytics, yeah.
Oh, nice.
Yeah.
Because I started.
Awesome. Okay. You want to go ahead and log in Firefox?
Really?
Any questions about that? Let's get you the.
Another 4 or 5.
Yes, right.
Exactly. Yeah.
Skill constant.
It is. It's
Great.
Shoot. Okay.
Oh, yes. And the actual content.
I'm going to use the.
That was great.
Oh, the bottom.
So it's very interesting.
Yeah, I really enjoyed doing it. Fun thing. And then like I figured stuff.
So
You know, more faster? No, we can probably go up to next.
Yeah.
So.
So I didn't have that.
Oh.
Good morning, everyone.
Good morning.
My name is Rowena Ebanks, and I'm an operations manager at Google. I'm also in the predictive analytics program at Northwestern. This is a relatively new field for me, and apart from learning, in fact, it's going to be a career change, but apart from learning this really fascinating field, one of the things that I've been really amazed about in this program is how it's allowed me to sort of redefine myself professionally, and I've been really excited about that. So people often ask me how I decided to get into the program, and I tell them it was a combination of really three things. One was I've been at Google for almost 10 years now, and 6 years in my position, and I thought it was time to learn something new. The second is that I actually toyed with early retirement. And I've read a lot of studies that say the earlier you retire, the earlier you die. So as a matter of fact, Newsweek just sent out this article a couple of months ago that said the same thing. So I'm not going to be retiring anytime soon. The third thing is that I have a little bit of a phobia about losing my mind. So I have read other studies that say the more that you exercise your brain, the more that you practice, the stronger it gets. So I decided that I would study predictive analytics, exercise my brain, and not lose my mind. So one of the really interesting things about working at Google is that we get to meet really interesting people. And really my studies started last year when I met Maria Schreiber, and she and I had a really interesting conversation about mentoring programs and how they were important to career development and personal development. The other really thing about working at Google is that every year they send out an employee feedback survey. And in the last one, we had about a 96% participation rate, which is pretty phenomenal. And one of the things that Googlers are really interested in are mentorship programs. They say that it's really important to career development. So based on those two things, I decided to volunteer to create and implement a mentorship program in my DC office, and we had about 28 participants. And so at this time, I also was taking my data mining class, and then I had to come up with a research topic. And so the professor said that we should pick something that would help us in our in business. And so I decided to do it on mentoring programs as well. So So for those of you not really familiar with data mining, there are themes in data mining, and these are really techniques that you use to help you reach your goals, reach your objectives. And so I used three themes: classification, clustering, and association rule learning. And are you familiar with these algorithms? Yes, okay, so let's move on. So I had three objectives, and this is what made my study a little bit unique, I think, is that I used three different themes and several different algorithms to achieve my objectives. And the first was, could I find a correlation between employee engagement and mentoring programs? The second was, could I define the most successful demographic, who got the most out of mentoring programs? And then the third one was, could I find a preferred format by the most successful demographic? So now that I had my objectives, I needed to find my data. And this is where I discovered that you really need the right data, not a lot of data, but the right data. Because I found a lot of data online, and none of it helped me. So what I decided to, so I was talking to a friend of mine about my frustration about not finding anything. And he suggested that I launch a Google consumer survey. So I thought that was a brilliant idea, and I did. So these are the questions that I asked. And for those of you not familiar with Google consumer survey, it's basically a tool that allows you to survey the web. It's really cool. And these are the questions I asked. I targeted people who had actually been in a mentoring program or were in a mentoring program. So my answers came in, and the survey ran for just a couple of days and it was pulled because of not a lot of activity. In other words, there weren't a lot of targeted responses. And so that was the bad news, that not a lot of people had actually been in a mentoring program. In fact, only 8% had been in. But the good news was that of that group, about 58% said that their employee satisfaction had actually increased as a result of the mentoring program. And then of the remaining 42%, most of them said that their employee satisfaction remained the same. And then the little red box there represents the 4% whose employee satisfaction decreased because of it. So, for my objectives, my 3 objectives, I wanted to see, I should run through this pretty quickly. I wanted to see how many, or if there was a correlation between mentoring programs and employee satisfaction, and I was able to find that was pretty easy. I didn't have to run that through any data models to figure that out. But then I wanted to dig into the data a little bit deeper and see if I could predict whose employee satisfaction would increase. And I ran it through classification algorithms. And was I successful? Not really. I really only could find, between the 2 models, I really only had a 50, the highest I had was a 58% accuracy rate. But since my goal here was to find out if there was a correlation, that really didn't influence my recommendation whether to have an employee, whether to have a mentoring program. So then my next objective was, could I determine a more successful demographic? And here I also wanted to dig into my data a little bit more. And so I found the most successful, and I also found the least successful. And then I categorized those 2 groups into currently or previously to see if I could find anything different. And then what I found was that the most successful participants were males in the Midwest, and the least successful people came from the South. So then my 3rd objective was, is there a preferred format? And what I found from my association rule learning algorithms was that they preferred a casual format. They preferred it shorter in duration. And then beyond that, they really didn't have any feelings about other aspects of the program. They really just cared that it existed. So now that I had everything, all the information I needed, if we're following along in the data mining process, we had to deploy. And so what was I going to suggest as a result of this? And it was, yes, it makes sense. Have a mentoring program, low investment, high return in terms of happier employees and hundreds of thousands of dollars in savings, if not millions, in terms of training costs, recruiting costs. And then beyond that, if I wanted to figure out something to do other than that, I would examine the programs that were in the Midwest and apply those best practices to the programs in the South, and then implement those programs in the South because I think they probably would really appreciate them. And then think about combining business data with mentoring data and see if you, for more compelling findings, can you find the correlations, can you gather insights from the correlations between performance and your workforce, and then that could have a significant impact on operating metrics and things like that. So then, what I was able to do, I thought that the results of my study would correlate pretty significantly with the results of my pilot program, and they did. And so I did make a recommendation to my leadership team to implement a mentoring program. Remember, I had 28 people. And so they reviewed everything, and a couple of weeks ago, my senior vice president said that she would be launching a June mentoring program for over 400 people in our organization. So I was pretty happy about that. Thank you.
So much. Okay. So our next presenter, come on up, and we'll get you set up here.
So,
So we'll start in about 5 minutes since we're back on track. 11:20.
Good to see you. Enjoy your day? Good? Actually, across the way. Yeah, I thought I would hop in and check up and all of that, so I kept it over.
Thank you. Appreciate it. Which one do you have here? You want to drag it?
We run a memory because you probably gave a couple of things we do with our program
Over in sales.
without stats. But we
No, it's just,
and it's very casual. Okay, and we don't even do declarations. It's just only two people who want to work, continue to work together. And
Go ahead. Okay, hi everyone, I'm Nia Louise. I'm a student at Northwestern University, but I'm also heading the analytics team at an online marketing agency based in Washington, D.C. And we do lots of work for a nonprofit organization doing online fundraising. So we do a lot of e-commerce for the nonprofits that almost all are based in D.C. I was initially an engineer working as a systems engineer with online banking. So I was always working with online systems and, going from just the basic banking transactions into nonprofits and now digging into big data. It just made me have a full view of online data and how big data can actually help organizations get more and more done. I'm going to walk you through, feel free to stop me for any questions. I'm also going to have a Q&A in the end if you need, but I just want to make sure everyone becomes an online marketer by the end of the session. Okay. So this is just an overview of what we're going to go through. I'm going to just introduce online marketing and search engine marketing to as the area, and then I'm going to see how that how we can use big data in that. So in big data, we all know that it's volumes of data that are available in varying degrees and complexity and ambiguity. Now, when we look at digital marketing effort, when someone is doing an online marketing campaign, you're trying to reach that customer by doing some email marketing. You email them, you see how many, do they click through the email, do they open the email, do they do all of that, and there's tons of tools that actually do that. There's SEM channels, which is search engine marketing. All of those ads that you see on Google, on Bing, all of those search engine, and this is where this is what this case study is about. So I'm doing only this as a proof of concept. Then the next step, which is my thesis, is going to be all of these together, flowing into big data. So you're getting a sneak peek of my thesis here. We do also a web traffic, what the user is doing on the website, what pages, what is he clicking on, how long is he staying on that page, which links is he, which images, which products on the website is he looking at. So it's more of the user engagement and the user experience on the website. E-commerce, is he actually purchasing anything? Is he making the final click that we want him to do? This is all data also that raised together, and when we put all of this into big data, we have a 360 view of the customer, and we can actually target those customers, reach them better. Okay, so this is a slide that's going to make you marketers now, online marketers. Now, if I went, I went in Google and search for learn big data, because I want to learn about big data. Now, the search results are start here. If you look at these, this is an ad. These are all a list of ads. Now, companies which are selling stuff for big data are fighting for this ad space. They do bids. So you do an online bid to show up on top or show up here, which is more prime. For example, let's say I tried, I clicked on this, which is learn big data, become a data scientist at Coursera. So if I click here, I had a click. So that ad got an impression, is a view that I saw it, and then it has a click through because I clicked through it. And if I, if I went on the website, looked around, and then I decided this is the course for me, I'm going to buy the course and I'm going to register, then I'm considered a conversion and a transaction. So for marketers, it's very important that we get the customer to click, to go on the website, and to buy. And knowing that full picture requires, a lot of data crunching together, a lot of systems going together to actually know what makes the customer actually buy. How does he go and do this purchase? What makes him leave the website and go away? So this is where we're starting to use big data, or I'm convinced our customers to use big data to actually get that full view. So if we just start with the keyword is what you search for. So I just searched for learn big data. You could search for anything else, for escape analytics or something like that. So some companies have up to 10,000 keywords that they do bid on. But if someone searches for learn big data, show my ad. So if you have 10,000 keywords, we usually drill down when we do reporting by match type. Am I matching the right keyword, or is someone, for example, searched for learn data? Am I going to show up? That's called the match type. Then sometimes we target only certain people on the ad. Like we're only targeting people on PC or mobile or tablet. So this is where we actually, drill down even further with the data. Then we look at how am I going to have an image ad? I'm going to have a text ad, a video ad, all of that. So these are different type of ads that we, advertisements that we show to the customer. And then we can also target by geolocation, which is I'm only going to target people in Chicago or in DC because I'm doing, for example, a regional marketing campaign. So if you think about it, you have 10,000 keywords. You go here, 10,000 by 3, that's 30,000. You go here, that's 90,000 rows of data. You go, oops, you go here, and you go into 100,000, and you reach millions. And that's just doing for a day. Imagine if I'm doing that for the whole campaign season or 6 months. I have millions and millions of rows of data, search results, people clicking, people buying, some of them in the city, some of them using mobile, some of them using Android, iOS, all of that. What do I do with this data? I want insights to actually drive my marketing campaigns. So when we put all of that data together, what we're going to do for, what marketers need is they want return on investment, ROI. So I don't want to bid on ads and pay to show ads that nobody's clicking on, or I don't want to show ads that people click on but don't end up buying anything, then I'm wasting my money. So this is where we want online reports that have real-time analytics to actually give me which keywords are working, which is not. You bid here, don't bid here. So we actually get the actual numbers to give us better ROI. So we're bidding on the right advertising campaigns. And then the second part of the search engine analytics is we do campaign planning. So at the end of this campaign, you pull all of the data, all of the reports that we said, millions of rows, and you do year-over-year trends. For example, in nonprofits, their heavy season is the end of year. This is where they send you, make a tax-deductible donation at the end of year and all of that. So we do a lot of learning of the past end of year season to market the customers, to market to the customers better for this end of year. And this starts, early on. We start in June, trying to, get all the learning from last year to market better. You want to do seasonal trends. When do people actually, start giving for end of year? When do people, give all of that? This is what the data will tell you. When you put everything together, you get trends, you get insights, and then you make decisions for your next campaign. This is a case study that I did for this white paper. It's called the Help Organization. The customer decided not to show their name because they don't want their competitors knowing what they do and how much money they make. But it's a nonprofit organization. It works on crisis relief, basically. So any crisis that's happening, helping people and all of that. So that's what they do the most of fundraising online. And for nonprofit, doing online fundraising is helps with ROI. It's a lower cost advertising channel. So what they wanted, what their objectives was, they want high ROI. They want to spend money online to get so much donations, for lower cost. They want faster results with audience. They want to know who should they target, what age range, which areas, and all of that to actually get the right, fundraising. And they want to also have some insight for their fundraising strategy. So how should they do, how should they market for the next campaign? And, if some crisis happened, how do they deal with it? The data sources, almost all the nonprofits love using the Google tools. So we use Google AdWords for advertising. It's an advertising platform to do those ads that I was just showing you. So you kind of load your ads on Google AdWords and you do that advertising. We use Google Analytics. Analytics is where when the customer goes on your website, it tells you everything that he did on the website. Pages he clicked on, which products did he buy online, all of the other stuff that we do, within the website. How long did he spend on that page? How, what's the overall time on site and all of that. And then there is a fundraising CRM. So when he actually makes the donation or makes the purchase, is he a new donor? Is he a returning donor? Did he make a one-time donation or a monthly donation to this organization? Now, the methodology that we use is we pulled all of this data into Hadoop, and we had data extract, and we used Hive to do the real-time analytics. We used Pig to do the trend reporting and the overall end-of-year campaign results. Now, for the results, I'm going to show you some snapshots from the Hive and Pig stuff. And this is because they wanted, their marketers are sitting there trying to see which keywords they should bid on to get more money. Because with nonprofits, they work a lot with also crisis relief. So for example, now the hot keyword for them is Nepal, what's happening in Nepal, earthquake. They want to act quickly to make sure they bid on the right keywords to get more fundraising, to get, help these people. So what we tried, the main two data sources is Google AdWords, where we have, the ad content. What was in the ad? Did it say help Nepal now? Or did it say, the earthquake or something like that? This is the ad content. Ad grouping, destination URL means, did they take them to a donation form directly, or did I take them to a video and then ask them to donate? So it's all these content that we do from the AdWords, which is the advertising side, and then this is the Google Analytics, which is after they click, did they actually, what's their bounce rate mean? Did they leave the website or did they stay? Is he a new visit? What's the revenue? Transaction, average revenue, like what's the average dollars for people coming from Atlanta, or what's the average donation from New York, or something like that. So this is just more of the engagement, and this is the advertising. And like I said, massive amount of data. We put it together, and then we run some queries. So we used Hive to do some queries, for example, on Typhoon. When the typhoon in the Philippines happened, they had a big marketing campaign running. And they just wanted to know which is the best performing ad group. We did, when we loaded all the data on Hadoop, we had like a kind of a dashboard that shows them top 10 ad clicks and from the ads. When we had the Ebola crisis, so they were also, that was a crisis. Everybody was searching online, what's happening, what's going on. This is where they tried to collect donation and we had the fundraising. So we actually merged the data to actually say, all of these keywords, they make so much money, but all of these other keywords that you're bidding on, they are for people who are coming to learn, but not to donate. So they adjusted their bids to match something which is more fundraising, and the lower cost they put it into people who they try to use a different approach. That they have some non-paid pages, so they do it for people who are learning. The paid pages they do it for fundraising. Also, some other stuff that we insights that we do is they wanted to know returning customers, someone who actually returned to my website. How did he come? Did he search for another crisis? And what we found out in the study is they're actually coming by brand name. So they were actually searching for help organization. And this is what they learned. They're like, oh, then we actually should, make sure that that brand name is there in all of our, marketing and all of that to establish that brand name with the customers. More here about, which ad makes the most transaction. They found the matching gift. You know how sometimes they tell you if you donate 50, the other company will give another $50. They found out that matching gift campaign, they actually bring in the most dollars because people say if I give 100, then it's another 100, then it's going to make more money. This is where they advertise more as well. They wanted also to do a big report to find low-value keywords and high-value keywords. So they just wanted a big report to see all the advertisers that made, per group, they made less than 5,000 or 100 to 5, more than 5,000 and 100 to 5,000. So low value versus high value. So we did I did a pig program that actually does a full report and extract it for them at the end of the campaign. And this is where we do lots of analysis and big data to actually for them to delve through and look at the data and all. So the transition that they liked after doing this case study, which is like a proof of concept for them, was they're not crunching so much data anymore because Hadoop is so fast. We just load the data and have those queries set up there for them to look at dashboards for the top 10 keywords, top 10 revenue generators, and all of that. They were able to slice and dice their customers. They know who are the low givers, who are the high-end givers, who are people who are just coming to learn and read. They found that so many people click, but they just want to become advocates instead of donors. So this is where they were able to get so much insight and segmentation. They found, this is faster and it's easier to integrate data together with Hadoop. So the big data adoption, like I said, all of what I presented right now is just here on that search engine marketing. I don't know if I click here, actually. So then we do, the next step is merging this search engine marketing with the web traffic, with the email marketing, and social media, which is all the digital marketing that's happening online. And then we have their CRM, which kind of knows everything about their client, their history, their transaction history, customer profile. We're going to also merge that. All of that is going to come into Hadoop. And then they also have some offline and direct mail, where they send, mail pieces to customers saying, donate now, and they put some link on the mail piece on the on the envelope or something. And this stuff, they come, some people receive the mail and they end up donating online. This is where we're actually going to pull the data and see whether what do they take? Because we noticed that we send the mail, 2 or 3 days after, the searches just peak online. And it's not because we did a campaign, it's because people just received the mail piece. So they go online and look up what's that. And this is where we find the correlation between the regular mail and actual search. They do some TV ads and phone ads. So we do lots of, offline coding here to read the results with online. And when we put all of this data together, crunch it together, this is where we have a full view of the customer. And because sometimes the same customer is donating online at one point and then doing the same thing on, after a TV ad. And after all of this, we get the 360 view of the customer. Then we have an informed strategy for the organization. and we have some valuable insight that we can actually, target the customer, have a better ROI, and have an actual informed campaign. We're not trying to change stuff. We're actually doing stuff based on facts. Any questions?
Yeah, sorry. So how long have you been using Hadoop at work? Like, is this a very new?
We're not actually using Hadoop. I did use Hadoop just for the case study.
Oh, gotcha.
This is what, like I said, this was a proof of concept for the client to actually tell them, how this works, or if this is also, works.
Right.
And this is now the customer approved to actually go ahead and, so they gave me just their search engine data. Now they gave me access to all of this, and this is going to be my thesis. So stay tuned for more.
Very cool, yeah. So, and also, what are you using to visualize? I guess you might not have gotten this, but like visualize the results you're getting out of
So they had Tableau in place.
Gotcha.
So we're using Tableau to do some of the visualization.
Like a direct connection, or are you pulling it out?
To pull data from Google, we're using Google APIs to pull like massive data from Google APIs and then into Hadoop. And some of the stuff, they come as pure extract. So they have their own reports set up in Tableau. They just want to, pull the data and just, plot it.
Right.
Yeah, but they're actually, after doing this, they're actually thinking more of how they can change the data warehouse to fit more and look into more results.
Cool.
Thank you very much.
You're welcome.
So you're going to use your laptop?
Yes.
Bring that up.
Okay.
Get that on. So we'll need to screen share. I don't know if it's not.
Very nice.
Thank you.
Sounds like it's really
What type of connections do we have going on here?
Yeah.
And then you can log in here, Google Chrome, Gmail on there.
Go ahead.
Okay, awesome. So you could then head over here to students. And you're actually going to be able to
So, do you go to school
You're going to use your
here
email.
or Western or
No, I do online.
online? Or where are you based?
My email and.
Oh, okay.
Yeah, so just head over to
I don't
students.
think we want to
Yeah.
Yeah.
I'm gonna add it in.
Yes, I wanted to ask about your direct marketing, and when you do mailing.
And if that doesn't work, go ahead and post an email.
Yeah, we use the
Send it
back
to
from the short URL.
Yeah.
So we do, for example, like help.com/give. When that works, we send people to a longer URL, which we put all the campaign against.
So you know where they.
Exactly, yeah.
Got it. How far are you into that?
For this evening, we're just starting.
No, for your,
Program?
yeah.
I'm done with the classes, so now the pieces. So this is when the real work now
Yeah.
starts.
Because I just started. Yeah, and I live in Sterling, Virginia, so, yeah.
Oh, interesting.
So you're gonna,
I have one more than
that's
online.
me that just keeps running.
I was just come here to do the presentation since the paper was chosen.
You're looking at this, you're.
I do online too.
Oh, yeah, it's with work and all that. To me, even having the whole program online, it was, I don't think it was, it's not very different from that.
now. So just like, you know, you can do stuff, but you don't have a mindset to get to the actual results.
We're ready.
Good morning, everyone.
Hello.
My name is Iron Williams. I am currently in the Master of Science program degree curriculum at Northwestern University. During my day job, I work for Coca-Cola, where I'm a finance manager, where I manage the volume forecasting and trade spend investments we make with our customers, and I specifically support the drug value channel. As many of my fellow students, we had an opportunity to take a machine learning class with Professor Sunil, and we had the great experience of applying hands-on experience to apply machine learning techniques to a actual live data set. So in my particular data set, I used a data set called the Acute Care Hospital Inpatient Prospective Payment System, IPSS for short, and pretty much it's the Medicare payment system. And in my particular model, this data set has 163,065 instances. There were 11 attributes. This was continuous data, and I did check for missing duplicate values and outliers. We spoke about data mining. In general, data mining is pretty much clustering methodology which identifies patterns, relationships, and trends based upon the data set. And I use Weka, because Weka, I don't know the correct enunciation, but I use Weka to analyze the data for my particular data set. So my key findings, pretty much, of the 163,065 instances across 11 variables. Let me explain. So what this data set is, it looks at the cost and the cost that medical providers, hospitals, submit to Medicare for common medical services. So based upon the data set, there were 6 distinct clusters that defined, that was driven by variations in common hospital services. Okay.
Tape on the floor.
Ah, I got you, sorry. You did say that. So, so there were 6 clusters. And the first cluster, just get my notes on here. So looking at understanding the relationships with the clusters, I was able to define the clusters of services with the greatest discrepancy in terms of what these hospitals were charging to Medicare. And these discrepancies are most likely to occur in 6 distinct clusters. So in cluster 1, there was the heart failure and shock treatments. So this particular cluster was identified in Long Island, New York. So medical providers in Long Island, New York had such a great variation in terms of what they were charging Medicare for these common health failure and shock treatments. And the average amount that they were charging Medicare was $29,810, but Medicare was actually only giving them or paying them $11,000 and change for these common services. Cluster 2, nutrition and metabolism. Orlando, Florida was the culprit for cluster 2. So on average, the discrepancy rate was around $21,244 that medical providers were charging Medicare, but Medicare was actually only returning or paying $5,821 to these medical providers. Cluster 3, Philadelphia, Pennsylvania. On average, the medical providers were charging $32,253 for chronic obstructive pulmonary disease, and Medicare was paying $8,120 for these common services. Cluster 4, severe sepsis, Los Angeles, California, on average was charging $61,401 for these common medical procedures, and Medicare was providing or paying $11,656. For the major, small, and large bowel cluster, medical providers in Baltimore, Maryland were more likely to submit such large dispersion in what they were billing Medicare. And of the 77,000 that these medical providers in Baltimore, Maryland was charging Medicare, 25,000 was what Medicare was actually returning or actually paying for these services. And the last cluster, those patients who actually went in for permanent pacemakers, the medical providers in Camden, New Jersey, were the culprits in this cluster, and they were actually billing Medicare for $62,656, and $14,000 was the actual payment. So in essence, there is opportunity to dig a little deeper into the clusters to see what's driving these dispersions between what these medical providers on Street A is charging versus someone, a medical provider around the corner is charging. So I think we have an opportunity to redefine what that formula looks like so that Medicaid, can actually be in line of what the true cost is for those treatments. We need more timely access to data. Some of the medical providers actually take 18 months after the year closes to provide this information to Medicaid. And I was looking for a more robust data set in terms of more time, of different time periods. I wasn't able to find that on the government website that I retrieved the data from. But with that information, I would have been able to define more of a classification model, which would provide some sort of predictive modeling to see which type of medical providers are more likely with some sort of predictive certainty to kind of overbill for these charges. So that's what I have. Thank you. Or any questions? I'm sorry. Okay. Thanks.
Running a bit ahead of schedule, so we'll do the next speaker in about 5 minutes. Thank you. And then we'll take the Google Chrome. Yeah, you can just click actually.
and you come back and what they do
Hey,
is
guys.
they advertise.
Looks like I got recruited. I was scheduled to speak this afternoon, so I was lucky enough to be walking up the elevator and, hey, you have some free time? Here I am. So my name's Jules. I work at Shutterfly. My title is Data Analytics Engineer. There's all kinds of titles out there, but basically I get to work with Hadoop, I get to work with R, I get to work with statistics, and it's sort of like an information buffet for me over there, so it's a great place to work. And I've got like 15 minutes or so. Let's get started. So this was based off of a final project, and it's an example of a proof of concept that I did at Shutterfly, and it's as a recommendation if you're like a practitioner like myself, or if you're a student, it's always a good idea to have a POC or a project you could show. And in my case, it's all about look what we can do with Hadoop and R and Tableau, and let's start to use it more. So it's kind of about, one, showing management how to move to big data and how to move to analytics tools. Also, it could be used for, hey, look what I can do if you're looking for a job, right? So it's a good skill set to have. I'll give a simple demonstration, hopefully I have time. The problem, so I'm at Shutterfly, like many companies, the data is just coming in. It's a deluge of data, it's a deluge. And we've got kind of the 4 V's. You've got your velocity, your variety, volume, and veracity. So velocity, data's coming in faster and faster. Variety, you've got social media just exploding. You've got the Facebook feeds, you've got the Twitter feeds. What do you do with them? How do you store them? How do you parse them? And if you use Hadoop, you could just have them all on that platform and then organize it from there. Or you could have a traditional database or a data warehouse whereby you want to move it into Hadoop for processing. And that's kind of how I did it in this case. So how do you handle it? It's kind of one big problem, and I broke it into 3 categories. It's the data growth. You've got, can we store it? Do we want to store it? And then can we analyze it? We have like 120, it's approximately 120 petabytes of data and growing. So if we've got that, do we have the tools to process it? That's a big challenge, and it's not easy. So data growing, tool limitations, and then you want to drive change. So this is an opportunity for a POC where we can demonstrate to management, to others, or to a professor, and in this case ends up here showing you guys. So next, the solution. Here was my approach in kind of creating the POC. You could have, you name it, at your company, or you could be a student and you want to use big data. You could use Amazon Web Services. There's some free options out there. You could also use Cloudera or Hortonworks VirtualBox and do the same thing I just did here. So you could, at home, walk through a similar situation with free data out there that is similar to this. And so I selected Hadoop because we have a Hadoop platform. And then 2, I chose Pig. It could be Hive, it could be Impala, it could be other Hadoop tools that you want to process the data with. And then Tableau, the latest presentation or paper I have isn't posted to the website. It just has the Tableau piece. But I do have an R piece. If you're interested in the R code, just come up to me. I'll send you the R code or the new paper. So you can do it at home and actually run through a script with R to do geospatial analysis. And that's what I chose as my POC. So here's my opportunity. I'm at work. I've got this data. How do I show off, one, Hadoop and a tool like Tableau or R? And so we have, in this case, customer orders. The first sample I did was 10,000, and then I did one with 10 million, just to kind of test it's something that's hard to do in Excel with 10 million. So here I have 10 million, right? And the proof of concept is to say, hey, I can do 10 million rows, but we're getting these 40 billion rows of data. We can't do that with your desktop or our current data warehouse. So we can scale this project. So basically, my POC, I chose it, geospatial analysis, so taking customer orders and mapping them over a map of, in this case, the US, and looking at where the hotspots are. And so let's move on to the next one. So this is the basic simplified version of what I'm working with. I've got the Hadoop HDFS, I've got MapReduce processing. Pig helps you do the MapReduce, so you write your Pig script and it's taking care of this piece. And so from So that's the basic stack I'm working with, a very simple version. If you download the Hortonworks or the Cloudera VirtualBox, you can do the same thing. And this is just a sample of what the pig scripts look like. Does this have a pointer? Yeah, it does. So that's the table I'm reached. So I'm saying load this file, which I had to blank out, and then the columns and what type of characters they are. It's sort of like a SQL, but not. And it's taking care of the map reduce at the bottom. So it's basically grouping. You're grouping product type and count with the zip code. So let me see if I can do a quick demo. Hopefully we have time. And let me know if this is not showing online. Okay, I'm going to sit here. I'm going to grab a chair. Might look a little more professional. All right, let's see if we can do this. So here's an example where I'm going from scratch. I've got my table. It's dumped. I'm going to process it. It's my summary table. And in theory, if you're crunching 10 billion rows of data, you have this summary table, and that's what I'd be processing. So going from scratch, let's see if we can do this. First time I tested it, but so this is an example of what you would do with Tableau. Very simple. You open it, you want to connect to your data. In this case, I saved it as a text file or CSV file. There it is. I'm going to open it. Open. And if your data is large, it tends to be better to connect live. This data set is not that large. First thing you want to do is go to background maps. Beautiful, the really cool thing about Tableau is you can pull maps pretty easily from online, from all over the world. Let's see, we want to be online, and this way it'll give you more detail. So let's say zip codes. We want zip codes here. We want our measures, the data field, and then boom. And it's super quick. Let's see what it shows us. Okay, all right, so here we go. We want to zoom into the US. Doing this in R takes a little bit more work, but with Tableau you can see it's very easy. All right, let's say I'm from the Bay Area. Let's look at the Bay Area. I want to change these dots are too large. You can easily change the size. Boom. So in this case, use case would be, all right, here's where our top 10 products at Shutterfly are the hottest. And if you want to look at, you can easily add functionality to the map, zip code. This is zip code data, so why don't we look at the zip code boundaries. So you've got zip code boundaries. If you want to zoom in to San Francisco, boom, you can zoom in. So it's that easy. And I'll get to it later why POCs are important, because this is very simple information and useful, but if we add some more layers to it, it becomes exponentially more interesting and useful for us. Next, let me move on. So next is R. I'll do a quick R demo. Doing good on time? That's one. All right. R demo. So this is an example of using R. If anyone's interested in analytics, you got to know Excel, and then you've got to know R like people know Excel. R and Python. It can be painful. So if anyone wants to play around with this data, just let me know. So first you would install the packages. They're installed. Take them on Wi-Fi. So then you would install, typically with R, you're installing a set of libraries. So I'm going to go ahead and run them. The first one is so I can get data in and out of our GData. Zip code has my zip code profile. So if I'm going to map data on geographically, I want to have geolocation data or longitude, latitude. So this package will pull in, it'll map my zip code to a longitude, latitude, so I can map it on a map. And then gplot, too, is a graphics component of R where you can do, I'm going to step out and say, cooler things than Tableau. You can make Tableau look kind of goofy and old if you use some of these packages. So it's a little more technical, but there's a lot of cool applications out there that are excellent for packages for R. ggmap is going to pull maps. So first line of code, I'm going to pull in my file. Second, I'm going to turn on these zip codes, pull in the zip codes. And then I'm going to clean my zip code. So this code kind of cleans out the zip codes that have the dash and the 4 more digits. It's going to remove those guys. Boom. Now I'm going to merge my file, which just has zip code, with the file that has zip code and the longitude, latitude. Then I'm going to convert the data into a data frame, which makes it easier to process in R, or enables you to. Here we go. I'm going to go out like Tableau did automatically. When I selected Go Online, it pulled the map. As I zoomed into California, it literally went out and pulled California data for me right then. So all this is done in the background. But in this case, we're going to go online to Google. This might take a minute, actually. Minutes. I'm also going to pull California. All right, so let's look at the U.S. So that's going to take my data, take the map of the U.S., my data. The ggplot2 is going to make it, put an image, turn the data into an image and put it on the map. And it's pretty quick. And you can change the colors. You have all control, full control. Let's pull in the California one. So let's zoom in. You can pull in satellite maps, whatever, you name it. There's all kinds of maps out there. So zoom in, boom. So that would be Shutterfly's top 10 products where they're hottest. And you could look at, which frequencies of which products are of interest. So that brings me to, that's kind of rushed, but brings me to the end here. It's like it's almost like speed dating, right? Yeah. So in the end, let's work it. All right. So in the end, POC, we discovered some basic insights, right? So I go to my boss. Here's what we can do, and he's like, yeah, that's okay. It's okay, but what about this and that? And then I talked to a shipping analytics, our director, and he's like, hey, can you add where the items were fulfilled and where they were shipped to? So we've got order, location, fulfilled location, and not the address, but the zip code of where it's going. So there, if we add those 2 data points, fulfiller and ship to destination, we can look at where are items fulfilled on the East Coast that were ordered in San Francisco. So they get shipped all the way across country. Happens for various reasons, but through this process, we can scale it up and monitor near real time. We use Spark and more advanced tools. You could do it real time with all the data. But this is close. We could have a query run on Hadoop, and we could have that table set, and we can process it, within at least that day. It could happen. So we're talking about a day latency. And conclusion, so these tools will work. Right? We just did it here, and you can do it at home. You could do this easily on a VirtualBox, testing. Let's see, what else? Next steps, yeah. I actually talked through all of this already. So yeah, the next steps for me, now I'm going back to the drawing board and just, simply adding those columns. And now I have a whole new dialogue with my shipping analytics director. Hey, here's your data, and we can actively monitor where items are fulfilled and shipped to. And he can tell you right away, you give him the number and the locations, what that cost is going to be. So that's the type of cost reduction activity that a POC like this actually will lead to in the real world. So we're going to be saving, a lot of money. That's all I can say. All right. Well, thank you very much.
I have a question.
Oh,
So,
yes.
if you, are you using this data to do more also forecasting for, shipping, or I don't know, maybe orders forecasting?
That is actually my next step.
Okay.
That's where I want to get into the predictive piece. And so I'm an analytics professional. I'm also a student at Northwestern University, the Master's of Science in Predictive Analytics. I'm almost done, half the class left, and then my thesis, so almost there. Analytics definitely opens the door. So now I know.
Now you know what to do with it.
Yeah.
Can you send me the article?
Yeah, sure. Maybe
yeah,
we can meet after. Or my email is just jules.malin@gmail.com.
Are you doing the thesis or the capstones?
I haven't decided yet.
Yeah, do the capstone. Yeah,
Tell you, like,
get it over with. Well, not this day.
I started the thesis and was like, it's just too long. At least the capstone you can be finished.
Yeah.
So the thesis is kind of
Do the
open-ended.
thesis.
I've been leaning towards the thesis because it's just, it's like.
I was leaning towards it.
I mean, if you like research.
Yeah, and you can always come back and do your thesis work after you graduate.
You can always do
so
research.
exactly.
We had to go there and hire your boys. Say what? They were like, oh, you can contact these people. Because ours was like personal. Did you write a thesis? Right.
Yeah, same thing for me. I want to do the thesis and do my own like fancy paper, but at the same time, it's like I want to be done.
Yeah. You can bring your own data set into the capstone. And so you probably have pretty much just do what you want to do, but at least you'll have 3 other people to support you.
Right.
Yeah, that's one thing I've learned. The biggest thing, and what I do now at work even, and when I'm not in people I don't work with, I recruit teams, Are you interested in this project? Are you interested? And together we can do so much more. Like casual competition, I couldn't have did it by myself. It was a team of us working on it. It's all done in a team. Like, the way to go is having a team environment.
It is, that was the thing. Like, it was when we started like sketching out the plan. It was going to be like 6 to 9 months, probably longer than that.
All right, thanks so much. We're going to squeeze in one more presenter for L31.
Well, hello everyone. My name is Jeanette. For those who don't know me, I'm a student at Robert Morris University, so I was finally somehow able to squeeze myself into, so I hope that you can bear with me for 10 minutes. I'm a graduate student at Robert Morris University, and soon, next quarter, I'm going to be graduating. I'm coming from English and literature teaching background, so this is absolutely new to me. Turkmenistan is the country that I'm coming from, and we don't know what the big data is about. When I came here, I was, especially through this research I've done, I was literally lost. I'm like, what is those numbers all about? I love speaking, not so much dealing with data. But anyway, under the supervision of my, yes, okay, good. Yeah, I'm good. Everybody can see it, right? So under the supervision of my professor, Qasar Muhiddin, we've conducted independent study. Everybody knows what the stress test is, and for those who don't know, it's just running the stress test for the banking firms in order to forecast and see what their performance, how will they perform, how did they, to see the risk, and how do they survive under the 3 economic scenarios. So the purpose of this research basically to leverage FDIC stress test data, which is macroeconomic data, to forecast firms, any company's performance using data mining techniques. So the agenda is today, as far as an introduction, I'll introduce you what the macroeconomic data is about, and about 3 scenarios of macroeconomic data, application and education. So what I'm going to be doing and what I did actually, we've taken the data from Robert Morris University, new enrollment, and we would like to see how new enrollment is going to be behaving under those 3 economic conditions. So, and the conclusion. So, as I said, I'll try to be short. So, let me quickly explain you what the 3 supervisor scenarios are. We have 3 scenarios, which is the baseline, adverse, and severe adverse. So the question goes back again, how could these different companies, not only banking, different companies could benefit from these 3 scenarios? So as an example, let me shortly describe you what the scenarios are. We have the data that starts from Q1 2001, and by the way, data is available publicly. The macroeconomic data is available publicly. So if you are interested to use that as well, please go ahead. And the data start from 2001 up to 2014. It's raw historical data. So we don't see anything from this point up to this point in any scenarios. Here we could see, this is, by the way, unemployment in entire country. So here in 2008, we can observe the recession, how unemployment goes up to 10%. So let me quickly, and then from here, this is a projection where actually we already see the forecast of 3 scenarios, what could happen. And this starts from 2000, quarter 2003, 2014, quarter 3. So this is the 3 projections. I would agree probably Mike Chase does it too, right? The stress test for banking.
Sure, we do.
But yeah, so the bottom line is here, as we can see, we have baseline over here. So baseline usually, what does that mean? It is going to be just following the same patterns with no spikes in economy. It's just just following whatever it was in the past. What does the adverse scenario mean? So adverse scenario, as you can see from here, it's going up. So unemployment, when country is experiencing mild recession, let's put it that way, simplify. And as you can see, there's a difference. The unemployment went up for 4%. So, and an adverse scenario, severely adverse scenario, it's when unemployment, it's a recession in the country, when we observe the recession in the country. So this is GDP. Let me show you the now closer look at the, again, employment. I think you guys got what exactly I was talking about. Here's again the base scenario, which is doesn't have any changes, smoothly going. Then we have our adverse scenario and then severely adverse scenario. So let me quickly tell you what the macroeconomic data is. As I said, it's publicly available, so you can guys use it for whatever companies you're working for. It consists of 26 variables. I used only the variables that are for United States, related with United States. So it has 3 subgroups, which is 6 measures of economic activity, which is GDP, CPI, nominal, real, so, and then interest rate variables, which is 3 months treasury yields, everything that is related with the interest rate. And as you can see, mortgage, especially these guys are going to be influencing our enrollment. And then the last one is the house price index, commercial property price, and United States stock market volatility. So I use all of those. And our next step was, after cleaning, it was crazy. We've run probably 200. And I had a lot of support. I had a lot of support that helped me. I was just bothering. I'm not going to get into details. So, and we used the tool, which is software SPSS. I'm sure you probably heard. That's a software, yeah. And the methodology was multivariable transfer function. So what it does, it takes independent, the spikes. We'll look at the past, we'll look at the history, we'll look at the past spikes of the independent variable, and look at how it would influence the current condition of dependent variable and the future. So looking at the past, we're predicting the future. Are you getting it? Yeah, so Dr. Gockerman, please, this is the first research in my life, so if you find somewhere deviating, you have all rights to correct me. So now, this is as I said, I'm trying to keep it short. Once we run the model, the REMA model, what we're looking for. The best model that the software chose, we have 4 independent variables. You might ask, how in the world 3 months treasury yield could impact Robert Morris University enrollment? I'm sure you're going to ask. You know what? I trust software. After 200 running of models, I said, okay, I'm just trusting SPSS, and I'm following it. Then at the end, I will become, usually, if I'm not mistaken, what we say, SPSS gives us the model, and now we're becoming artists. We are the ones that are choosing. So now, as an artist, let's say, I chose those 4 variables, independent variables that impact and that are significantly impact the enrollment at Robert Morris University. So what are we looking for? When we're looking at the REMA model, so and as I said, I will try to keep it more business, less technical, because I'm not a technical person at all. So we're looking at estimates. This is what we need. We see that 3 months treasury yield has a negative impact. Just look at this negative sign. Negative impact on our enrollment. What does that mean? some of you would agree. Well, since 3 months treasury yield is somehow correlated with our interest rate. When interest rate goes up, what happens to enrollment?
That goes down.
Exactly. The enrollment goes down. Why?
It's cost.
Because cost. Students cannot take loans. I don't want to take loans. I'm not personally taking loans because I don't. So, and I agree with the first one. I said, perfect, it's understandable. So that we have triple B deal. Triple B, I did so much research from my educational background, coming from Turkmenistan. I'm like, what does in the world this mean? We don't have triple B in Turkmenistan. So anyway, but it has positive impact on enrollment. And prime rate somehow has also positive impact on our enrollment. And Dow Jones has impact. So another important thing for SPSS software, which we're looking for, is seasonal difference and delay. So what does that mean? So since I love 3 months treasury yield and I spend a lot of time with it, I kind of had date with it, I could say. So I will explain you from this one. So seasonal difference means, as you can see, we have number one. When 3 month treasury yield increases, it will have a seasonal effect on our enrollment one season in the future, 1 year in the future. So this seasonal difference means 1 year ahead. So if right now, let's say, the 3 months treasury yield increases, goes up,
Oh, you'll feel that.
then exactly, the new enrollment at Robert Morris University will be affected negatively 1 year in the future, like 1 year. Sorry for my English. So, and what does delay mean? So delay is seasonal is 1 year. Delay is quarter. So again, whenever 3 months treasury yield increases, that will have 1 quarter effect on our enrollment, like with a delay, 1 quarter delay. So again, it's almost the same like this one. Dr. Bokerman, I'm in the right track. Yeah, you're just sitting there like, okay, what is she talking about? So this, and the hollow, also one of our best students, so she's also can, correct me if. So one quarter. So if 1 month, if 3 months treasury yield goes up, enrollment will be impacted with a delay of 1 quarter. You get it? Good. Let me not confuse you anymore. It's by the way, it's significance. The less is the significant level. It has to p-value has to be 0.05, and the less it is, the better it is. So all of our 4 variables are significant. So now this beautiful table, what does that say? Don't confuse yourself. Just we're looking at 2 numbers. This whole table tells us about how accurate the model is. So we're looking at the stationary R-square, and we're looking at the significance. So the higher, the closer the numbers, the values, both of these values to 1, the better fit is the model is. So as we can see, we have 69, which is close to 1. We're good. And then we have 75% also, which is close to 1. So we're good. We finally found from 200 models 1, which sometimes in my mind doesn't make so much sense, but what is the result? So finally we got to the point where we can actually predict the future of Robert Morris University. So here, let me show you. You're probably looking at this graph, and what does that mean? So we see new enrollment, and the data start from 2014. Do you remember those 3 scenarios that I told you about? So now we have our actual real data. This is our actual real data enrollment, because enrollment, the enrollment data starts from 2006 and up to 2015 quarter 1, which we're at right now. So as you can see, the purpose of this we would like to make a prediction as closer as possible to the real one. Would you agree? Yeah. So, and from this one you can see, like, you see, this is the yellow one is the real one, and the red green, which is our what? Adverse, and then the blue, it's a base, and the severe they're very close. When you look at this from statistical or non-statistical, it's a perfect model at this point. So now we can go and use this whole prediction and see from what could happen. Our base is blue one, so as you can see, it's following this pattern, and we have the spike, which is in Q3, and it's our fall. It's going up. Usually, why the enrollment goes up and fall? Yeah, I told you I like to speak. So I'm going to be done soon. So we have here spike over here, which is again fall 2016 and fall 2017. Perfect. And our other scenarios, such as adverse and severe, also closely, or not organized, but placed next to each other. So, Robert, VP, Catherine, I would like to tell you, there's not a huge difference. If economy goes down severely, Robert Morris University is not going to be too much affected. So we're fine. We're fine. Thank you. If you have questions, please go ahead and ask me.
This is Morris Graduate School data, wasn't it?
Yes. I don't know how much I was able to give you information. Maybe I confused you. Maybe I just please let me know.
That's great.
Thank you.
Thank you to all our speakers. Greatly appreciate it. We are now going to have lunch back on the 8th floor in the culinary student kitchen. Very nice kitchen up there. We're back in here at 1:30 for those that are doing the PM open forum sessions. Thank you all. See you soon.
The elevator.